Hey guys, hello everyone. Welcome to Rasayan Academy, all of you. So recently I have started a poll on my YouTube channel, that is what do you want me to do in the upcoming videos, and most of you I've seen have voted for basic organic chemistry, and many of the students have also voted for GATE previous year questions. So we will be discussing these things side by side, and today I'm going to start a very simple topic from a very simple topic of organic, that is IUPAC nomenclature. I have started this topic because it is actually very basic, but still many students find it difficult to name some compounds. And if you are getting this, if you get this topic, if you understand this nicely, you will be able to score a few marks in your GATE examination and CSI and NET examination, and you're not going to do silly mistakes in naming or selecting the correct option for a molecule, right? So we are going to be discussing IUPAC nomenclature, and we'll only see the easiest things. That is, we'll only see what is required. Okay, we are not going to study extra. And also there will be other topics following this. That is the other topics of general organic chemistry. We are going to discuss all of it. And guys, it took me a while to start this because I was busy with my Unacademy classes. As you know already, I'm an educator on Unacademy. So for those students who are following me over there as well, I want you all to see these short videos, because they are very short, and then they are going to help you with the basics. Okay, so yeah, first of all, we are going to start understanding how to give the IUPAC nomenclature of organic compounds. All right, guys. So it is actually very simple. Just like you know a language, it will become a language for you. Okay, once you understand, it will become a language. So easily, just like easily you speak a language, you will be also able to name an organic compound very easily. Okay, so what are the components of IUPAC nomenclature of an organic molecule? Very simple. Let's just write the components first of all. So first of all, we have something called a root word or a word root, whatever you want to call it. Okay, this is the first basic thing, root word. Now, before and after the root word, you are going to place something which defines the other part of the molecule. Let's say I am placing a primary suffix over here. All right. After the primary suffix, I might also place a secondary suffix. What is primary and secondary suffix? That I'm going to discuss. Let's say this is a secondary suffix. Before the root word, I'm going to place an infix. All right. And before that, a prefix. So infixes are not so usually seen. Only for few molecules you see the infix. Other than that, you mostly see the prefix only. All right. So what are these? What do these mean that we are going to discuss? First thing, guys, the root word. Let's talk about this. The root word or the word root. This forms the basis of your nomenclature. It gives you the length of the carbon chain. Okay, it is compulsory to be written, and this gives you the parent carbon chain. How are we going to select the parent carbon chain? That we will discuss very soon. But this is going to give you the idea about the parent carbon chain. Okay, and how do you select the parent carbon chain, guys? Let's follow up with another color. You select it with the parent carbon chain is going to be the one which has maximum carbons or maximum functional groups. I'm writing F groups over here, that is functional groups. Okay, or maximum number of double bonds or triple bonds, double or triple bonds, or maximum number of substituents. That is our parent carbon chain. Okay, so this is what I'm writing, guys. See, the arrows are going to move in this direction. That first, what is root word? It is the parent carbon chain. And then how the parent carbon chain is selected? By maximum number of carbon, functional group, double, triple bonds, or substituents. This is what you are going to remember about the root word. Next, we move onwards to what is a primary suffix. Primary suffix tells us about the saturation or unsaturation. About the saturation or unsaturation. Okay, and these two components, root word and the primary suffix, they form the basis. Both of them together, they are absolutely compulsory. They form the basis of an name of an organic compound. All right. Yes. Now, guys, saturation and unsaturation is very simple. Let's say if you are having all right, let's write it with another pen. Let's say you're having saturation, carbon carbon double bond throughout, and you have four carbons, you will call it butane. So but is for the root word that you're having four number of carbons, and for a carbon carbon single bond you will write ane. For a carbon carbon double bond you will write ene, and for a carbon carbon triple bond you are going to write ine. Okay, we will discuss this further as well. This is just for the idea. Then comes the infix and the prefix. Are they necessary? Infix is not so necessary, not compulsory. Only it is seen when you are having some cyclo compound or some bicyclo tricyclo compound or some spiro compound. Okay, so this name, the nomenclature, cyclo, spiro, bicyclo, that is infix, and that is not seen for all the molecules. Okay, so this is optional. What about prefix? Prefix is very necessary when you are having substituents. Okay, so when do we use the prefix? We use the prefix when we are having, let's say, side chains, when we are having side chains to our molecule, okay, some other branching carbon chain like that. Second, when we are using this, when we have substituents with lower priority. Okay, guys, this is so important that substituents with higher priority become the secondary suffix. This is so important. Okay, substituents or functional groups. I will write functional groups are considered. Functional groups are actually substituents only, right? But functional group with the highest priority are considered the are considered for secondary suffix. So I would write that substituents with highest priority come over here. Substituents with highest priority will come over here, and those are going to be behaving as the functional groups. So substituents with lower priority end up in the prefix. Okay, substituents or functional groups with lower priority. Okay, now this is comparable. Who is going to be prefix and secondary suffix? This is going to be comparable, right? So when there are more than one functional group in the molecule, that will be based on the priority order. Who is going to become the prefix? Who is going to become the suffix? That is so important. Okay, and this is the most confusing thing for most of the students. All right. Now we are going to discuss. See, you have already understood that what is a root word, your parent carbon chain. What is primary suffix for saturation, unsaturation? What is infix? It is optional but only used for cyclo, spiro, or some other molecules like this. Prefix and secondary suffix are constantly competing in between each other. That is, with the greater priority, you write in the secondary suffix, and with the lower priority, you write in the primary suffix. Alright, so this is the basic rule of IUPAC nomenclature. Now we move onwards, guys, and we see the root word table, because this, I told you, is going to consider the maximum number of carbon atoms. So number of carbon atoms in the parent chain, if it is 1, you have the root word meth. If it is 2, eth, prop, but, and so on as the number increases. Okay, so we have pent, hex, hept, oct, non, dec, undec, that is undec is for 11, dodec is for 12, 13, tridec, tetradec 14, pentadec, hexadec, heptadec, octadec is 18, nonadec is 19, and icos, that is for 20. You have heard borane structure icosahedron, right? So that icos is for 20 when you have 20 carbon atoms or any other atoms, right? So yeah. Now Let's talk about the primary suffix, that who behaves as a primary suffix. Type of carbon chain, guys, it is very, very important. Primary suffix is basically that you use just after the root word. Okay, so there was your root word. Here you use the primary suffix, then the secondary suffix. Okay, so this was used for saturation and unsaturation, right? So when you're having all the bonds saturated, you use ane, butane, methane, ethane, and so on. When you have one carbon carbon double bond, you have ene. Okay, just say butene. This simple molecule is but2ene, specifying the position also. But2ene. Unsaturated two carbon carbons double bonds you are having, let's say like this. It is diene. We will call this 1, 2, 3. So one position and third position double bond starts. It is buta 1, 3 diene. Okay, then you have one carbon carbon triple bond, you call it ine. For example, this is CH triple bond CH. This is going to be known as ethine because there are two carbons and a triple bond, it is ethine. And two triple bond, it is going to be known as diene. How is that possible? Diene, look at this. There is one CH over here, C triple bond C and one CH, obviously, because carbon is tetravalent. This is going to be buta 1, 2, 3. 1, 3 and diene, like this. Okay. So I hope that you have understood. Unsaturated one carbon carbon double bond and one carbon carbon triple bond is going to be your ene-ine system, and this will be separated by the numbers that we are going to give. Obviously it is ene and ine, but we need to give it numbers, that where is the ene and where is the ine, and what about the priority, that also we will discuss. Okay. Now, name of the functional group. See guys, here we are talking about the prefix and the secondary suffix. I told you that root word is already fixed. It is the parent carbon chain. Infixes in, we are only getting the infix. For example, the infix we are only going to get when you are having the cyclohexane, for example. This is cyclohexane. So this cyclo word is the infix. Okay. So I just hope that you have an idea about this. We are going to do examples. Then you will know further about infixes. Right. Now we are understanding that infix is done. Prefix and secondary primary suffix is also done. We are understanding about the secondary suffix. So there is always a competition between secondary suffix and prefix. Okay, let's see. Name of the functional group representation, that is how they are looking like, and there are two criterias, that is suffix when the carbon of the functional group is part of the parent chain. So if any of these functional group is part of the parent chain, then it will be taken as a suffix. If they are not part of the parent chain, then they will be taken as a prefix. Okay, so I will just give you some examples later on. First, let's see the name. Carboxylic acid will be known as oic acid when it is part of the chain, and if it is not part of the chain, it will be known as a carboxy. So let's consider this example, guys. Yes. So what is this molecule? This is 1, 2, 3, 4 carbons. So that's going to be a but. And first position, we start the priority over here. 1, 2, 3, 4 like this. It is butanoic acid. Butane and oic acid. Because everything is saturated. So butanoic acid. So that is why the oic acid was included. It has become the suffix. Okay. The oic acid, it is included in the chain. If we are talking about this molecule, then how do we say? It is cyclopentane carboxylic acid. Okay, Why? Because this is not included in the parent chain. This is your cyclomolecule, cyclopentane. This is the parent chain, cyclo. Cyclo is the infix over here. And this carboxylic acid has to be written as a carboxylic acid suffix, okay? Because it's not in the parent chain. So the carbon of the functional group is not a part of the parent chain, but still this is the only functional group. That is why, since it is the only functional group, that is why it is written as a suffix. And if there was more functional group having a greater priority than COOH, then the COH will go to prefix and it will become a carboxy. We will also see various examples on that. Keep that. I'll be sharing another video number 2 for this. So very important, guys. IUPAC nomenclature. Will see many examples to discuss all of these rules. Next is acid anhydride. You have oic anhydride if it is the only part of the parent chain. If it is not part of the parent chain but only functional group, you call it carboxylic anhydride, and it is not having any name for prefix. Okay, it can only be taken as a suffix. Okay, this is also important. Then you have ester, you call it alkyl OH. Okay, alkyl carboxylate, alkoxycarbonyl. Okay, so all of these examples, guys, just go through the table. We are going to do the examples in the next upcoming video. All right, that how we can use all of them in the nomenclature.